Okay, so next I'll do a couple of graphs from 6-3. So 6-3, we graphed the square root, just equations, and then also the inequalities. So here's some 6-3 stuff. All right, so first we are going to graph this equation. Okay, so first thing you do when you're graphing these is we start with our original 3 points. So the original 3 points for these are always these same 3 points. So as long as you have these memorized, then you shouldn't have to worry about, this first part of these problems. So second part is the new. So the x values and the y values have the potential to change. The x values are going to change based on what you have on the inside of the square root. So if we have an x minus 3, you always do the opposite for x. You do the same for y, but you always do the opposite for x. So if we see an x minus 3, that means that we're going to be adding 3 to all of our x values. So for this first one, 0 plus 3 would be 3, 1 plus 3 would be 4, and 4 plus 3 would be 7. So that's our start. Those are the x values. Anything that's not under the square root is going to change the y, and it's going to do exactly what it appears it's going to do. So we've got a -1 on the outside, and then we have a +2 behind the square root. So multiplying always comes before adding or subtracting. So what we do with these is we start with these initial y values, the 0, the 1, and the 2. First, you take that number and you multiply it by -1. And then you take what you get from that and you add 2. So 0 times -1 is still 0, plus 2 would be 2. 1 times -1 would be -1, plus 2 would be +1. And then 2 times -1 would be -2, plus 2 would be 0. So these are the 3 points that you'd get. So we want to start by graphing them. Okay, so 3, 2 is right there, and 4, 1, and then 7, 0. So when you're graphing these, keep in mind that this first point is always the starting point. You don't go to the left anywhere, so it's kind of like a ray, except it's a curve. So it starts with this point right here, and it goes through all 3 of them, and there's always an arrow off to the right-hand side like this, but there's never an arrow off to the left. Like this is always just where the graph begins and ends. You will not see anything past this point. So that's what the graph looks like. You guys will also be asked about domain and range. So the domain is all about the x values. The range is all about the y values. So here's how you figure it out. You look at these first points right here. This is your very first x value. So then you want to use this as a starting point and then see what the pattern is doing from that point on. So the x values start at 3. And then from that point, we go to 4, we go to 7. So they start at 3, and then they go up from there. So that means my x values can be greater than or equal to 3. Then do the same pattern for the y values. My very first y value is 2, and then you can see it goes to 1, to 0. So my y values start at 2, and then they go down from there. So I would say y is less than or equal to 2. So these two numbers right here are always these two numbers that you have, and the inequalities always have the or equal to because you do include these two numbers. The greater than or less than depends on how the pattern goes from there. So from x, I started at 3 and went up to 4, up again to 7. So I said this is a greater than. For y's, I started at 2 and went down to 1, down again to 0. So I said less than. Okay, so that is what your graphs and your domain and range would look like for the equations. I'm going to show you an inequality as well. Okay, so this one, first note, you've got f of x, you've got y. That doesn't make a difference. F of x and y are basically interchangeable. So whether you see one or the other, it doesn't make a difference which one you see. What is important is the equation versus the inequality sign. So because this is square root, you're going to start this off the exact same way that we did up here by writing down your original 3 points and figuring out how to make changes to them. So remember what I was saying with this one, the only thing that's going to affect the x is what you have on the inside of parentheses here. So this is an x minus 1. So you always do the opposite. X minus 1 means you actually add 1. If you had x plus 1, that would mean that you would subtract 1. So this means I'm going to add 1 to all of my x values. So 0 plus 1 is 1. 1 plus 1 is 2. 4 plus 1 is 5. So those are my new x values. My y values, if there's a number out front, I would multiply the y values first, but there isn't. So the only thing I'm doing is subtracting 4. Remember, y values do exactly what they look like they're going to do. So I'm going to start with these 3 y values and subtract 4 from them. So 0 minus 4 is negative 4. 1 minus 4 is negative 3. 2 minus 4 is negative 2. So you start by plotting these 3 values. So first point is 1, negative 4, 2, negative 3, and 5, negative 2. So we've got these 3 points. Remember, just like the equations, you don't go beyond this point off to the left. With an inequality, you have to check to see if you have the or equal to, because the or equal to would make it a solid line. If you don't have the or equal to, like in this example, it would make it a dotted line. So without the or equal to, we are going to have a dotted line here. So it'll look like that and go off to the right. And then the greater than tells you to shade above. If you have a greater than, you shade above. If you have a less than, you shade below. So the greater than means I'm going to shade above. Make sure that this is kind of a boundary that I'm not going to the left of, and then you just shade everything up above that dotted line. So it should look like that. Okay, so those are the 2 different things that you guys had in 6-3.